Hello everyone, welcome to AI Anytime channel. In this video, we are going to explore the carbon emissions related to software. This is a non-AI video, guys. There's nothing to do with artificial intelligence in this video. Directly, but indirectly, of course, you can bring some of the layers of large language models, to make the app a bit better. This video is going to be important if you have some interest or if you have interest in the field of sustainability. I myself uh, have immense interest in these areas sustainability. I have built multiple products for the clients at my workplace, internally to measure carbon emissions, the carbon footprints of different types of initiatives that can be, mainly the software based solutions or the technology initiatives. And I have seen uh, most of the companies, the Fortune 500 companies or the IT services companies or whoever, they have sustainability at their topmost agenda, but they are clueless uh, on how to uh, basically measure, track, offset, whatever. It's mostly in the papers. Uh, I've seen that in the industry when I talk to my friends at different companies they're working, and I've seen that that's everywhere. Now, with the rise of AI or the heavy compute heavy models, now this is even more terrible if you don't have a methodology to basically calculate the emissions. But we're not going to focus on those parts, those require those are different scope. In this video, I'm going to show you a different methodologies that will help you measure carbon intensity, not the carbon emissions. Both are different field altogether, guys. So carbon emissions is like have different scope which are involved, where you measure the end-to-end emissions. That level that basically kind of contains the carbon emission factors based on which geography you are, what's the emissions, hardware, softwares, every scope is scope 1, 2 is scope 2 is scope 3, everything is involved. I'll tell you what those different scope means. My focus in this video is to be on the surface and to find out the first layer, which is the carbon intensity for any software, and how does that get calculated. I'll show you that. If you are someone who wants to do a new venture, wants to do something in this field, this video is for you. If you are someone who is working in the field of ecology or sustainability, and if you want to find out how do we calculate, then this video is for you. If you have someone who has bloody no idea about sustainability, then don't waste your time, even to watch this video. Uh, let's jump in, guys, and see what are we going to do in this video altogether. Now, if you look at here on my screen, I have something called Green Software. I have a bunch of websites which have been opened. Green Software, GSG Protocol, ISO 14064. I'm going to explain each of these. Okay. And how are we going to write some code, build a simple Streamlit application to calculate the carbon intensity for a given use case. That's the agenda, guys, of this video. Uh, as I said, we should be clear enough that we are not going to, uh, you know, let me just bring up my tab so I can just explain that with you guys. Uh, yeah. Let me just bring it here. Yeah, so when you talk about SCI, so SCI is the full form for software carbon intensity. That's SCI. And carbon footprint basically covers all the activities, for an entity. That's different. So at a huge organization, that's really difficult. When I say that they are clueless, the clueless is because the organization is so huge that probably it's very difficult to streamline everything. That's the challenge, but at least you can become a bit specific, because specific is terrific, as we say, right? So SCI is specific to software, and we're going to focus to SCI, software carbon intensity. We're not going to focus on the emissions part of it. I have a video earlier on the emissions. Please check that out. I'll give the link in description. Now, the purpose is that SCI is geared towards improving software design and deployments for better carbon efficiency. See, it's related. So SCI is related with carbon emissions, of course. That it has direct relation, too. But if you are able to bring a mechanism in at your workplace for SCI, software carbon intensity, then you will design and develop better softwares. So you can really do you can become efficient when it comes to carbon neutral. That's the plan. uh, Methodology is simple. It's a SEI, the specific calculation I just said, that incorporates software specific factors, but the carbon footprint has general standard applicable to your entire workplace. You have a scope one, scope two, scope three, more downstream. If what your employee is commuting from a petrol vehicle or a diesel based vehicle, how much hours they use their laptops, if are they consuming the electricity in office, everything. So scope one, scope two, what kind of food they are eating, at office and in the commute and at the home, everything is like. So when you come from top to down in the hierarchy, the scope becomes narrower. So scope one, scope two, scope three. Scope three is the most difficult to calculate, capture, which is more individual, very difficult to capture it. But yeah, organizations and startups are doing it what they have to do in the world. But if you have some ideas, this video is will very helpful. You can just get inspired by this, build an amazing product for the sustainability market, and why not. So if you look at here on my screen, let's jump in. And I'm going to say we're going to talk about SCI, and I'm going to talk about a use case. I'm just going to bring up my tab here. Just give me a moment. Yeah, let's just bring up that here. Yeah, this is where it is. And my monitor, and we're going to talk about here, guys. Okay, let me just select a color, and I'm going to write SCI, okay, which is nothing but software carbon intensity. And it is more project based, guys, more software specific. Okay, so that's what it is. And this calculated, and I will talk about, first let me write the formula quickly, and we're going to go through the formula. Okay, so the SCI is nothing but E into I, and I want to explain each and everything, and that is plus M. E, just go a bit up, plus M, and then you divide it by R. That's the formula of SCI, guys. So let me just make it a square so you can find out E multiplied by I plus M, and then all divided by R. That's what software carbon intensity is. Now E that you see here, let me just write it over here. E is nothing but E is energy consumed by the software. So E is energy consumed by the software. So let me just write it over here. And how do we calculate this? I will show that. Okay, and this is going to be in, so energy in, we are when we talk about energy in the software, let's talk about in kilowatt hours. That's how we're going to measure this is going to be the unit of it. Now E is energy consumed by the software, and I is the carbon intensity. So let me just write it over here. So carbon intensity of the energy, carbon intensity of the energy, and this is going to be in kg CO2 per kilowatt hour. So per kilowatt hour, it is going to be in kg CO2. Okay, that's what it is. I, and then M is, and once we write the code and once we build the application, you guys will understand this better, and we'll take a use case. Now M is embodied carbon of the hardware. So you're gonna use some hardware that can be, even if you go a bit deeper down, that can be GPU as well. So embodied carbon of the hardware. So let me just write it over here. Embodied carbon of the hardware in kg CO2. And then we have, what else, we have R. So R is nothing but it's the functional unit of the software. This is important because we're going to talk about this functional unit of the software. Functional unit of the software, like these are, if you have built a payment, now imagine if you have built a payment application where somebody comes in and pay money to buy something, then you will have transactions, then you have number of users, then you have number of hits, whatever. So functional unit is nothing but just a matrix that basically tells you like number of users, transactions, etc. That's what it is. So let me just scroll a bit down. Yeah, I hope you got the idea of this. Now we're gonna build an application with some given use case as well, and we'll see how we can do that. So it's very specific metric designed to measure the carbon efficiency of software based on the amount of carbon emissions associated with each functional unit of the software output. So For instance, this could be per user, per transaction, per unit of data process, and things like that, depending on what kind of software you have. Okay, and this is how we calculate this. It's SCI is more of a granular approach, focusing on the carbon efficiency of software across different units. That's what it is. Okay, now how gonna build this application, guys? So let's build the application. Okay, and then we'll see. Okay, and these are the methodologies. So the formula that you see about SCI, I'm just looking at my tab and monitor. This is fine. At least you guys can see this. Let me go. Now, SCI is based on Green Software Foundation. Okay, the formula that I have written. Okay, it says we are building a trusted ecosystem of people, standards, tooling, and best practices for green software. So Green Software has come up with this software carbon intensity methodology, the formula that I was showing you. But if you really want to go a bit deeper into how to build a product for sustainability or carbon emissions altogether, then you have to look at GSG protocol, Greenhouse Gas Emissions Protocol. They are the organizations which set the standards for scope one, different scopes, one, two, three. And then you have to other methods like ISO 14064. That these are all certifications that you probably have to go through it. So these are important for you to understand, guys. So scope one is the direct emissions that are by owned or controlled by the sources. Scope 2 is an indirect emissions. Okay, and scope 3 is even all all indirect emissions which is on personal level, which is not has nothing to do with the organization itself. Okay, so that's what the different scope that these you can find it out over here. When you read them, go through it and read it to develop a bit of understanding. Now I'll take a use case. So let's take a use case here, and let me just bring up my tab again. So I'll just bring up my tab. Where is that? Yeah, let's bring up the tab. Yeah, and we're gonna build a Streamlit app. But first, let me write the use case. What's the use case here? I'm gonna explain that. And to, now the use case is, imagine there's a company called Ecotech Solution. So company name is Ecotech Solutions rather. Okay, and they are specialized in developing AI driven energy management system for commercial buildings. Okay, so I live in a city where real estate is really booming in India, guys. Okay, so now imagine the Ecotech Solutions. I own Ecotech and I build AI driven energy management software for all the commercial buildings in the city. That's what my role is. So I'm going to write it over here so quickly. So energy MGMT software or system, whatever you call it, for buildings or rather commercial buildings. Okay, whatever. Okay, because they will be focusing on more sustainable thingy. Okay, now and we basically deploy on cloud. See, all the top hyperscalers, they have at the server side like Azure, GCP, AWS, they have carbon calculators. On the server side they would have it. So if you are using their services, you will be able to calculate and measure it everything. But what if it's on prem, it is the client side and everything, then you have to probably develop something. Okay, now uh yeah, and let's look at then, guys. Okay, so eco, and the task is we're gonna build we're gonna build a tool, very simple tool, eco optimizer. So let's build eco optimizer. So we're going to build this in Streamlit in a bit. Eco optimizer, I'm not going to write the code, I'll just show you how you can do that. Eco optimizer, okay, and that has an AI powered software deployed on cloud servers. This software monitors and optimizes energy consumption for commercial buildings. That's what it does, providing real time adjustment to you know their HVAC systems, lighting and other energy consumed asset. So for case study, let's take some parameter. I have to look at my notes for the case study parameters. Now imagine if we have a case study parameter. So case study parameter, and the first thing is energy. So let me see how much I have noted it down. So energy, let's for example 0.05 kilowatt hour per transaction. So per transaction, this much of energy is being consumed, 0.05 kilowatt hour. Okay, now the second thing is carbon intensity. This will become dynamic, guys. Right now I'm just keeping it just to build the app. So carbon intensity, which will become I, and it's again it can be mixed of both renewable and uh, non-renewable sources, guys. Okay, in the cloud providers region. So for example, not all the clouds are carbon neutral. Most of them are, they claim it, but you have to check that out. So carbon intensity, I'm going to keep it 0.4 kg of CO2 per kilowatt hour. That's what we discussed on top. It's mix of both renewable and non-renewable. Now carbon intensity is done. Then embodied carbon. Embodied carbon, and let's keep that M. I'm gonna keep that 200 kg. So 200 kg, considering the manufacturing and end of life emissions from the cloud provider, again, cloud services. They basically uh, okay, let's don't go deeper into it. That become a different topic. So embodied carbon, and what else we have? We have functional unit. Okay, so functional unit, which is R. So functional unit, which is R, and I'm gonna keep this per. Let's keep per thousand transactions processed by the software. Now this become our now we're gonna build a Streamlit app here, guys. Okay, for, and we call it Eco Optimizer, enabling Ecotech Solution. That's my company to measure the and track the. This is not my company. This is a company which does not exist, guys. Okay, this is for video. Okay, track their software's carbon footprint and explore opportunities for reduction. That's the plan. Now I'll give this screen grab. Probably if you need formula, if you need the bit of description, I'll give that, but you can also see that in code. So let's just go through the code. So let me do one thing. I was running here somewhere. Okay, so this, and is it open in VS Code? You can see I have an app.py. I've created a Streamlit app. So only Streamlit, that's something you have to install. Streamlit is a Python library. You can use anything else you want, okay, to do that. In app.py, I'm gonna come here. I already created a gist just to save some time. I'm going to copy it, but I'll explain the code each and every line and just paste it. Now, if you look at the code here, what we are doing from top to bottom, guys, we are importing the Streamlit, and then we are giving a title Eco Optimizer Carbon Footprint Calculator. Let me do an Alt Z. I also have commented it. We write introduction. We say this tool calculates the software carbon intensity for Eco Optimizer and AI powered energy management system for commercial buildings by Ecotech Solutions. So give a bit of introduction about the app. Okay. Now I have an input. I have four inputs. The first input is energy consumed per transaction, E in kilowatt hour, which I'm given a default value because we have to give it. Let me first run this and then I'll explain the code. Streamlit run app.py, and let's explain that. Go back here. This, let me just make it a bit bigger so you can see this clearly. Yeah, why not? Now come back here. We have carbon intensity of the energy, I in kg CO2 E per kilowatt hour. The default value is 0.4. Again, we have, for all this value that you see, we have about two floating point. After two floating point, we will round it off. Okay, so embodied carbon of the hardware, which is M in kg CO2, and functional unit transactions processed per thousand. That's the functional unit. This will all become dynamic and depending on what kind of infra, what kind of software that you guys are building. Okay, now I have a button that calculates the software carbon intensity. I'm saying let's do it for 3 years. So 3 years are the service life. Okay. So days in service life, which is 365 into 3, and daily energy consumption for R transaction. So R is per, here we have per thousand. So for R transactions, daily emissions, what we are doing, we're saying, okay, get the E into R by thousand, because if you look at the functional unit, transactions processed per thousand. Okay, this value will all get changes depending on how you want to do it. Now the daily emissions, daily operational emissions, daily emissions into I is nothing but the carbon intensity of the energy, and then daily embodied emission, M divided by days in service life, daily share of embodied carbon, and then I'm calculating the SCI, which is, you can find it out over here, daily emissions plus daily embodied emissions. Okay, I calculated it, run it off, and just written something just to make that. Now, if you see this, if you calculate again, you can increase these numbers and all, but if you just calculate, it says calculated SCI 0.203 kg CO2 emissions per day for 1000 transactions. So you can find it out over here. Okay, 0.203. If you increase, decrease, If you increase this, this will become different. Okay, so energy consumed per transaction, you have this, but what if I make this 0.1 knot? And if you calculate, you can find out it increases that as well. So if you keep increasing it, it will increase and decrease. That's how you can calculate software carbon intensity, guys. And you can extend this further. Okay, I'll give this code, probably a very simple HTML code in, or I'll share the gist in description. I'll share the screen grab in description. You can also watch my previous videos on carbon emissions calculator for softwares. That was a bit more comprehensive. That has some correlated calculations as well. I'll give that link in description as well. And if you are someone who has interest in, you know, carbon accounting, carbon calculations management, things like that, then please uh, start building solutions, guys, in that field. This will be really helpful for the community as well, or make it open source something or something like that. Okay. Now, if you have any question, thoughts, or feedbacks, please let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content I'm creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create uh, more such videos in near future. That's all for this video, guys. Thank you so much for watching. See you in the next one.